Okay, today's lesson was about graphing absolute value functions, and I wanted to show you some cool things about graphing all functions. And so we started the day with a worksheet, and it had these type of equations. It asked us to graph y equals the absolute value of x, y equals 2 times the absolute value of x, 5 times the absolute value of x, and negative 3 times the absolute value of x. And what we really wanted to know was, what does that number in front of the absolute value of x do? What does it do when you multiply a number by the absolute value of x? So I'm going to use a program called Desmos Calculator, and I'm just going to type y equals m times the absolute value, ABS is what we use for absolute value, of x. And I'm going to create a slider. And so here, m equals 1, and we get this graph, y equals 1 times the absolute value of x. Well, as m increases, if I multiply it by 2, I get that, or if I multiply it by 3, I get this, or 4. And so as I'm multiplying by a number, it looks like this v, or the absolute value function, is getting narrower. And if I go to the negatives, it goes reflection over the x-axis. So what we say is, as I multiply m here times the absolute value of x, it is going to change the slope of the sides of the absolute value function. Some people like to say it gets narrower or wider or steeper and less steep. But basically it's changing the sides of the absolute value function, the slope. So then we did the same thing again, only now we're adding or subtracting a number inside of the absolute value function. So we have y equals the absolute value of x minus h. So what does this h do? It's inside the absolute value. So I go back to my Desmos, and I'm going to erase what I have already, and I'm going to try a new function, y equals the absolute value of x minus h. And I tell it, okay, we'll have a slider for h, and I'm going to make this 0. So this again is y equals the absolute value of x, because h is 0. Well, what happens when h is 1? Well, if h becomes 1, it looks like it moves to the right 1. And if h becomes 2, it moves to the right 2, and 3, and 4, and so on and so forth. And if I go the other direction, it goes the other direction. So if h is a negative number, it goes to the left. If h is a positive number, it goes to the right. And remember, we're subtracting the number. So some people say it moves the absolute value or the v right or left, or you can word it as it changes the x-intercepts of the function. So again, here, if the number that we're adding or subtracting is inside the absolute value, it changes the x-intercept, or it moves the absolute value right or left. Then we said, well, let's take the number outside of the absolute value, such as these. And so now we're doing the absolute value of x plus some number or minus some number. And we're calling that k. So I go back again to Desmos to do this. And I can type y equals the absolute value of x plus k. And we'll have a slider for k. And I'm going to make that 0 to start. So this would be the absolute value of x, just like before. But as we change k, if we move it to 1, or to 2, or to 3, or to 4, notice the v is going up. And as I make it smaller, the v goes down. And so some people say that this k moves the absolute value function up or down. Or you can say it changes the y-intercept. And so again, adding a number after the absolute value changes the absolute value function up or down. So overall, we looked at an equation like this. Y equals m times the absolute value of x minus h plus k. And so m changes the slope or steepness. H makes it go right or left, or changes the x-intercept. K makes it go up or down, or changes the y-intercept. And why this is really cool is if we change the equation to y equals m times parentheses x minus h to the nth power plus k, we now have an equation which can work with all types of functions. And as we change m, it still changes the slope of the function. As we change h, it changes the x-intercept of the function. As we change k, it changes the y-intercept of the function. And the nth power is what changes the function itself. And we can do other things. We can change the parentheses to absolute value, or we could change it to square root. And the m, the h, and the k still do the same thing. And so this is what I like to call the everything function, because it does a little bit of everything. And once you know this, you can pretty much graph a lot of different functions without the use of a graphing calculator. Well, talking about graphing calculator, if I want to graph absolute value, I need to show you how to do that. I'm going to add a graph. If I want to do the absolute value of something, we, again, just type ABS of x, and we get absolute value. Now, if you want to see where they cross the different points on the grid, you can hit Menu, you can select View, you can select Grid, and if you want a line grid or a dot grid, it's up to you. I'm going to choose line grid. And so now I can see what it would look like on paper, on graph paper. Also, if you like a table to do the graphing, remember you can always hit Control T. And when you do that, it builds the table off to the side as well. And so I can scroll up or down and get certain points to plot. So that is graphing an absolute value function. We also had some vocabulary. Absolute value function is the V-shaped graph. The parent function of absolute value is y equals the absolute value of x. That's the basic equation. Then we have piecewise function. A piecewise function is where you take different equations for different parts of the graph. And so you could say from -5 to -2, it's just y equals x. And so you have this linear. And then from -2 up to 3, it's y equals x squared. And so maybe you have something that looks like this. And then from there on up, it's absolute value function minus some number. And so it might look like this the rest of the way. And so you can actually put different parts of equations together into what's called a piecewise function. And the last one, step function, just looks like steps. And it could be something like, how much does it cost to mail a package? And so for the first 5 ounces, it may cost $3. And then once you get to that point, anything above that, the next 5 ounces, it costs, $6. And then from that point, for the next so many ounces, it costs, $7. Who knows? And it just keeps going up. And so there's this time period where it costs the same amount, and then when it reaches some point, it moves up. It keeps jumping. So it looks like a stair step, and that's called a step function. So there's the short version of Lesson 5.8. I hope it helps.